A thermal power station is a type of power station in which heat energy is converted to electrical energy. In a steam-generating cycle, heat is used to boil water in a large pressure vessel to produce high-pressure steam, which drives a steam turbine connected to an electrical generator. The low-pressure exhaust from the turbine enters a steam condenser where it is cooled to produce hot condensate, which is recycled to the heating process to generate more high-pressure steam. This is known as a Rankine cycle. The design of thermal power stations depends on the intended energy source. Fossil fuel, nuclear and geothermal power, solar energy, biofuels, and waste incineration are all used. Certain thermal power stations are also designed to produce heat for industrial purposes, for district heating, or desalination of water in addition to generating electrical power. Almost all coal-fired power stations, petroleum, nuclear, geothermal, solar thermal electric, and waste incineration plants, as well as all natural gas power stations, are thermal. Natural gas is frequently burned in gas turbines as well as boilers. The waste heat from a gas turbine in the form of hot exhaust gas can be used to raise steam by passing this gas through a heat recovery steam generator, HRSG. The steam is then used to drive a steam turbine in a combined cycle plant that improves overall efficiency. Power stations burning coal, fuel oil, or natural gas are often called fossil fuel power stations. Some biomass-fueled thermal power stations have appeared also. Non-nuclear thermal power stations, particularly fossil-fueled plants, which do not use cogeneration, are sometimes referred to as conventional power stations. Commercial electric utility power stations are usually constructed on a large scale and designed for continuous operation. Virtually all electric power stations use three-phase electrical generators to produce alternating current, AC electric power at a frequency of 50 Hz or 60 Hz. Large companies or institutions may have their own power stations to supply heating or electricity to their facilities, especially if steam is created anyway for other purposes. Steam-driven power stations have been used to drive most ships in most of the 20th century. Shipboard power stations usually directly couple the turbine to the ship's propellers through gearboxes. Power stations in such ships also provide steam to smaller turbines, driving electric generators to supply electricity. Nuclear marine propulsion is, with few exceptions, used only in naval vessels. There have been many turbo-electric ships in which a steam-driven turbine drives an electric generator which powers an electric motor for propulsion. The energy efficiency of a conventional thermal power station is defined as saleable energy produced as a percent of the heating value of the fuel consumed. A simple cycle gas turbine achieves energy conversion efficiencies from 20 to 35%. Typical coal-based power plants operating at steam pressures of 170 bars and 570 degrees Celsius run at efficiency of 35 to 38%. With state-of-the-art fossil fuel plants at 46% efficiency. Combined cycle systems can reach higher values. As with all heat engines, their efficiency is limited and governed by the laws of thermodynamics. The direct cost of electric energy produced by a thermal power station is the result of cost of fuel, capital cost for the plant, operator labor, maintenance, and such factors as ash handling and disposal, indirect social or environmental costs.